Two variables correlation analysis. Let's see how we can do a two variable correlation analysis in our studio. How we can run a two variable correlation analysis. In order to do this, first and foremost, let's import a dataset. Now to import a dataset, my dataset is located in R, and this is where my dataset is located in R. In this particular document, R programming, and this is the dataset I'm going to use. So in order to do that, I have to install a package that can help me to import a dataset from R, and the name of that package is the readxl package. So I'm going to run this particular package. This particular package is I'm going to use it to install my dataset in R, and this is to install. Then I'm going to use a library to activate this particular package. Okay, now you can see the first one is with quotation while the next is not. I already installed it. I'm going to run this line of code. Then you're going to run this line of code. I already have these packages installed in my R. So all I need to do is to activate it. It's already activated in my R. So I go to package and I'm going to check on that, the readxl. Now you can see it's already activated, but if it's not activated, all I need to do is to run this second line of code, and that will activate that particular package. So the next thing we need to do, we have to install the dplyr function. So we have to install this particular package, the dplyr function. That's the package I'm going to use. Let's see. Okay, let's install the dplyr function. Okay, I'm going to delete this here. So I'm going to run this line of code to install the package. I'm going to run this to activate it. But I've already installed those packages in my R Studio, so I don't need to install the package any longer. Again, you can see a grammar for data manipulation and FC to manipulate your data set. So after that, now we can compute the correlation coefficients in our data set. So let me bring in my data set. So let me call the data set car sales. I'm going to use the read, and okay, and let me use this. Okay, then the next I'm going to do, I'm going to bring in my data set. Now when you go to, I'm going to bring my file. I'm going to load my file in R. This is a file.xlx.xlx. Now I'm going to use this to import my data set in R. But before that, you have to ensure that you are on the working directory. Now this file is already located in your working directory. And when I click on this, you can see that this file, this is my working directory, and you can see this R programming. That is my working directory. So I'll go to home. I go to home and then I click, for instance, I happen to click, let me see, I click on Python. Okay, I click on Python and I run this line of code all over again. Now I run that line of code all over. Sorry, I'm still on the R programming. Sorry, if you want to change the working directory, use set working directory. Okay, and you can use a set working directory. Yeah, so once I click on all this and I paste this here, now I change this to, okay, you can see the Python there, the Python. Now you should go and see how to import data set in R, and this training is not for that. Okay, this Python. So the moment you run this line of code now, and then you run get working directory, it gives you Python. So but now this time around, R programming. So my file is located there, and I've shown you my file in R programming. So go and learn how to import datasets in R. This video is not for that. So let's see the R programming. Now this is my R programming and this is my file. If everything is done correctly and there will be no error then. So let's run that. Okay, and let's see and get a working directory to confirm that we are on that working directory. Fine, we are on the working directory. So we can import this file now. Okay, now it's telling me car object 4xlxx not found. Okay. You run that fine. Okay, now we can see our dataset here, and this is the dataset, and that is it. So this is a dataset. So we can see our dataset. We have the sales, we have the type, we have the price of the vehicle, we have the MPG, that is represent the fuel efficiency of the car. We have the engine size, and we have the type of vehicle. We have the sales, and we have the MPG. So now we've gotten that. We've installed our deployer function we've gotten. So we want to try to compute the correlation. Let's see if we have this. Now the correlation we use, see, now you can see the argument for the correlation coefficients. We have the X, we have the Y, and we have use everything method because to see that whether you want to compute the Pearson correlation analysis or not. Okay, now the correlation analysis we want to compute here is remember our data set is car sales, the dollar sign, and we are interested in sales of vehicle and the fuel efficiency of that vehicle. So the vehicle and the fuel efficiency represent the MPG. Now you can see the correlation coefficient telling us it has a negative correlation coefficient. Now I want to compute the R square for that. All what we need to do is to align this, and that helps us to compute the R square, that is raised to power 2. And we run this particular line of code, and that gives us the R square. And if we want to compute the significance of that, all what we need to do times the test. Now fine, we've gotten that for the test, and then okay, now let's run this line of code and let's see. Now you can see the estimated value, the Pearson by default, how compose the Pearson correlation coefficients. Now you can see the T value, you can see the P value, and we can see the alternative hypothesis true is not equal 95% confidence interval. Now we can see the correlation statistics is this, and we can see the test. Now look at the t-test is this, and the p-value is telling us is not significant. So that the correlation between the sales of car and the fuel efficiency is not significant. That there is no correlation between the sales of car and the efficiency of car or that particular car. So we can also compute this. We can also compute this. And okay, if we want to compute for different types of significance, we can compute for that the different types of significance. We can compute for that. Let us see if we want to do the test. Now let's run this line of code. Now running this line of code gives us test. You can see the position of the text. You can see the argument x, y. Alternative, we want to run the two-sided or one-sided and greater than. So by default, I'll compute that for the two-sided. Now you can see the method. We have the C, the Pearson correlation coefficient. So we can just copy that there, and we move to this without a comma, and we paste that. Now, if we want, by default, I'll compose the Pearson correlation coefficients. The Pearson correlation coefficients. If I want to compute that for Spearman, all I need to do is just cut that off. and run this particular line of code. Now it's telling me that there are ties. Because of the ties, is not actually running that. So if there's ties, I think we use other. If there's ties, we can use other. If there's ties, we can use the other correlation coefficients in doing that. So let's see exact. Now, when we look at this exact here, it's telling us that a logical indicating whether an exact p-value should be computed used for Kendall and Spearman correlation coefficient if that should be there. Now it's telling us in running that cannot compute exact p-value. So cannot compute exact p-value, but nevertheless it computed the Spearman rank correlation coefficient. Now you can see, but it's telling us it's not exact p-value. So we can talk here exact p-value. You can see the force, okay, and let's run the line of code. Okay, now you can see the error is not coming up there. The error is not coming up. You can see the real statistics. Now you can see the real statistics there, and then we can see we have same real statistics. But when you look at the p-value, the p-value here is different with what we have here. Okay, it is still the same p-value, but nevertheless we said don't compute exact. That is why the warning is doesn't pop up. Okay, now you can see that there. Now you can see the real statistics. So if I want to compute from, but once you should know that the Spearman correlation coefficient and then the Kendall. Now once your data set is normally distributed, it will make use of the Pearson correlation coefficient. But once your data set is not normally distributed, then you go for the Kendall and the Spearman correlation coefficient. Now the Kendall is can be used when there is a small data set and there's a ties among your data sets. Also, we can use the Spearman correlation data set. That is, once the normality assumption is not satisfied by your dataset, you can use either the Kendall or the Spearman, but the Kendall goes for a small dataset, and when there is ties among those datasets, the Kendall can also work. So here, if I want to check for the Kendall, I can also use to check here for the Kendall correlation coefficient, and all what we need to do is to run this particular line of code, and it computes the Kendall correlation coefficient. And also, if we want to compute a one-sided or a two-sided hypothesis, that is the alternative. Now we have alternative here. Alternative could be two-sided, less or greater than. Now, when you are working with a Kendall, and you might run into a problem with that. So let me remove all this. Let me remove all this. Okay, let me rather make this. By default, it's using the Spearman. So let me use the Pearson that we use the Pearson by default. Let me remove this off from this. Okay, and let me run this particular line of code. By default, it runs the Pearson. Okay, now I want to now you can see it's running that. So let's see. Okay, let's assume we want by default it runs the two-sided correlation coefficient. So let's see. Let's say we want this. Let's take out this. And let's say we want less than, that is negative. We are expecting the correlation coefficient between the Pearson correlation coefficient between the sales of car and fuel efficiency of car to be negative. So we use the less than, the one-sided correlation coefficient. Now you can see the T statistics is minus 0.275, and that you can see that is the same thing we got here. But the moment you use the other one, that's the greater than, the correlation coefficient is negative. So it's negative. If you are expecting it to be positive and it's decided to use a positive, you run that here, you can see it still gives us that similar value, but it's not giving us an error. But when you start bringing in the candle and running the alternative set statistics, and you can see that. So these are how you run correlation coefficient statistics in